Today we're going to solve two-step and multi-step equations. So if you were going to go to a party or a friend's house for the very first time, they give you directions. So you follow those directions. So you get to the friend's house. Now it's time to go home. So you get in your car. Are you going to start where you started before? Are you going to go at the top of the page down again in order to get home, or are you going to have to work from the bottom back up? And so at the top of the page, you started at your house. You ended at your friend's house at the bottom of the page. So you're starting now at the friend's house, so you should be starting at the bottom of the page. And as you go back up, if you turned right getting there, you must turn left to go home. So it's going to be in the opposite. Order of operations says that multiply, divide comes before add and subtract. But that's like going to the house. That's when x is all by itself on one side of the equation. What we're doing now is x is not alone. So when we go to disconnect, we have to go bottom up from order of operations. So we must disconnect all add and subtract first, and then multiply and divide. So if we look at this first equation, we know that x is not by itself. X is connected to 3 by multiply. It's connected to 5 by subtraction. So we've got two things that we're going to have to disconnect, and add subtract gets disconnected first. So because 5 is subtracted, I'm going to add 5 to the left. I will add 5 to the right. So this is going to be 0. Negative 5 plus 5 is 0. So I'm going to end up with 3x equals 17. You will justify each step. What did I just do? And I should show my operation. I did the addition property of equality. All right, so now we ask ourselves, is the x by itself? No. X is attached to 3, and it's attached to 3 with multiply. So in order to disconnect multiply, we're going to have to divide. So we're going to get x is equal to 17 thirds. What did we just do? We did the subtraction property of equality. All right, so this is a new day. Hopefully you have labeled this or we could just call this multi-step equations, because we're going to do more than just this. And at this point in time, you should have written the note in red and the work and the problem that I've shown so far. So here's another one. We've got 12 minus 5x equals negative 17. Notice x is not by itself. 12 is connected to x through subtract. 5 is connected to x through multiply. Because x is not by itself, we're going to do order of operations in a reverse order. And so you may look at this and say, well, 12 is connected to 5x by subtraction, but it really isn't. I could change my subtraction to addition, at which point 5 turns opposite. So 12 is not being subtracted, it's 5x that is being subtracted. So I'm going to choose to disconnect 12 by adding the opposite. If we add the opposite, we tend to not make a mistake when that subtraction sign is by the 5. 12 and a negative 12 is 0, so I'm going to have negative 5x equals negative 29. Now, in this case, I did the addition property of equality because I added a negative 12. Could you have subtracted 12 from both sides? Yes, you could have. Then your justification would be the subtraction property of equality. All right, so now we look at the 5 and we look at the x. We are connected by multiply, so disconnect, we're going to need to multiply by or divide by negative 5. So this is going to become a positive x. This is going to be negative divided by negative is positive. So we got 29 fifths. What did we just do? We did not do the subtraction property. We just did the division property of equality. All right. Now notice that's about as complicated as a two-step gets. At this point, you need to put me on pause, and you need to write down this problem. And our goal, because I didn't bother to give you directions, is I want you to solve for x and justify, that's a J, justify each step. Okay, so it's time to pause. I'm going to move on. and we're going to work on multi-step equations. This needs to be done, and it needs to be done now. So put me on pause. All right, so welcome back, and we will check your answer tomorrow. Our goal now is to be more than one step. Each side must be simplified first if possible. We're going to isolate the terms with the variables on one side, constant terms. Constant terms means terms with no variables, numbers, on the other side, and then we're going to finish solving. So if I want to solve a multi-step equation, so at this point, hopefully, you're pausing me so that you can write what is in red. If you have my outline that has been printed, then that's already printed for you. So if I look at this multi-step equation to start with, here's my equal sign. Notice I have variables on both sides, and I have constant terms. This is, let's see, I'll use blue. 3 and 11 are your constant terms. Your 9x and your 4x are your variable terms. So you have to, first of all, can you add 9x to 3? No, because they're unlike. Can you add 4x to negative 11? No, they're unlike. And the reason why is 4 has a variable, 11 does not. So as far as my first step of simplifying each side first, I can't do it. It's already simplified. So now I'm on to step 2, which is isolate the terms with the variables on one side, constant terms with the other. So I'm going to choose first to disconnect my 4x. I'm going to move 4x to the left. Eventually, I'll move 3 to the right. Now, you can move 9x to the right and 11 to the left. It's up to you. But right now, we're going to focus on the 4x. So I'm going to subtract 4x from this side, and I'm going to subtract 4x from this side. All right? Even though this is 11's being subtracted, not 4x, remember, we can change our subtraction to addition, which makes more sense for this disconnecting through subtraction. So I have 5x plus 3 equals negative 11. How did we get there? This time I used the subtraction property of equality. All right, so now we look at this. If you notice, this looks just like the problem you just finished doing in the 2 examples I did before. I have x. Now, x's are all on one side. X, though, is attached by 5, and it's attached by 3. So I've got addition, and I've got multiply, which gets disconnected first. Hopefully you said addition. So in order to disconnect this addition, I'm going to subtract 3 from this side, and that means I'm going to subtract 3 from that side. So I'll end up with 5x equals negative 14. What did I just do? I used, again, notice, the subtraction property of equality. All right, so now notice x is still not by itself. It's connected by 5 with multiplication. So in order to disconnect the multiply, I need to divide. So my final answer is going to be negative 14/5. And what did I just use? I used the division property of equality. I love equation solving. These are just fun. All right, so if we look at the next one. Again, if I look at this, my variables, I have variables on both sides. I have constant terms on both sides. I cannot subtract these because this has a variable. The 4x has a variable. The 8 does not. I cannot subtract these because 15x has a variable, or I should say I cannot combine these because 15x has a variable and 9 does not, which means that this is as simplified as it gets. So I'm going to choose to move my 15x to the left, and I'm going to do that through subtraction. All right, so now I'm going to have 8 minus 19x is equal to 9. All right, so now I have x connected to 19 with multiply and 8. Again, I'm going to make this plus a negative 19. You could have kept it addition if you want. I do better when I change my subtraction to addition. I have to disconnect my addition, so I'm going to choose to subtract a, let's see, what did we just do here? I forgot to justify. This is the subtraction property of equality. Hopefully you caught that. Subtraction property of equality. All right, so now I'm going to subtract 8 from both sides. So I'll end up with negative 19x equals 1. What did we just do? Again, we use the subtraction property of equality. All right, now what is connected to x? It is 19 through multiplication. So in order to disconnect multiply, I'm going to divide both sides by negative 19. So I have x equals negative 1 over 19, and this is the division property of what I used of equality. All right, so, this is great. We've done this, but I think, let me look to see what's next. I think I want to go back to this problem. And this is what I want to do. I want to take this right here, and I want to redo this first step. If I have 8 minus 4x equals 15x plus 9, I could have chosen to add 4x to both sides, at which point I have x is equal to 19x plus 9. Now, that would be the addition property of equality. Then I would have had to subtract 9 from both sides, and I would have had 19x equals negative 1. That's the subtraction property of equality. Then I would have done my division, x equals, notice we get the same answer. This is the division property of equality. Now, I've always moved my variables first. Does that mean you have to move the variables first, or could you have done the constant terms first? You could have done the constant terms first. So if I look at this equation, I think I'm going to choose to do the constant terms first because I haven't done it that way. So I'm going to choose to add 9 to both sides, and I'm going to put my operation here so you know what I've just done. So I have 6x equals 7x plus 0. This is, what did I just do? I just did the addition property of equality. All right, so I'm going to simplify, actually, so now what I'm going to choose to do is I'm going to choose, because 0 and 7 are attached to x, I'm going to choose to subtract 7x from both sides. So this will be negative 1x equals 0. What did I just do? I did the subtraction property of equality. And then I'm going to divide, and I'm going to show that step. Got to see the work, because I've got to know what you did. So this is going to be x equals 0, and to get to this step, I did the division property of equality. Here is another problem, and I believe this is my last example. I'm going to choose to move my 9x to the other side. I am subtracting 9x because it is positive. So when I do that, I will end up with negative 5x plus 8 equals, this is 0. That is negative 12. Notice on this one I did not change my subtraction to addition. And one of the errors that is very common is that little subtraction sign, which is negative sign, ultimately gets lost in the translation. What did I just do? I used the subtraction property of equality. All right, from here, I have negative 5 connected to x, 8 connected to x. 8 is being added, so I must disconnect all my add and subtract first. So I have negative 5x equals negative 20. I just did, again, the subtraction property of equality. All right, so now x and negative 5 are connected through multiply. So in order to disconnect multiply, actually I'm going to choose to disconnect multiply because I didn't really talk about this yesterday. Okay, let me put my negative 5x back up there. I'm going to do something different. I'm going to choose to multiply by the reciprocal. So the reciprocal of negative 5 is negative 1/5. Well, this is going to be negative 5, top times top, bottom times bottom, which is negative 5 over negative 5, which is 1x. This is going to be negative 20 over 5. Actually, negative times negative is positive. So that's going to be the same reduced down to 4. So now when I justify this step, it's going to be the multiplication property of equality because I chose to multiply both sides by the reciprocal. Did I have to do that way? No. I could have divided both sides by negative 5, at which point I would use the division property of equality. Reciprocal is really helpful when the coefficient Coefficient is the number. Negative 5 is a coefficient. It's the number attached to x when the coefficient is a fraction. All right, so now it's time for me to stop talking. It's time for you to start doing. So our goal here is for you to do this problem, and the directions for this problem is to solve for x and justify. I believe that this is indeed the end of the notes, so I need you to get this done. I need this problem highlighted, justified, so that when I look at your notes tomorrow, I see that you did all the U tries.